All right, today what we're going to be focusing our time on is talking about the law of sines and the law of cosines. Now, we got a little bit of taste of the law of sines a little bit last week when we did this number one as our warm-up question for the day. Now, what I would like for you to do is take some time and again, just refresh our memory, our answer to number one. And once you've done that, answer number two. So as a class, you can either work with the person next to you or as a group, and you can work on this problem individually or, like I said, or you can work on this with a partner. Okay, so pause the video and we will talk about this in just a second. Again, work on this with a partner or by yourself. All right, taking a look at this question. Okay, taking a look at this. I have find the ratio between the sine of A over BC and the sine of C over AB. Well, if we look at this, A is 60 degrees. So really what's happening here is in this first fraction, we have the sine of 60 degrees over BC. And BC, if we look at this picture, BC is the side opposite. That's 60 degrees. In this case, it's 5 square roots of 3. Okay. And let's compare this with sine of C. Well, C is 30 degrees. This would be sine of 30 over AB, which again is the side opposite of 30. AB is equal to 5. Okay. Well, if I take a look at this and I put this in my calculator to find the exact value of the sine of 60, well, let's put this in our calculators, and the sine of 60 is 0.866. If you were doing this on your own or with a partner, you should have gotten the sine of 60 to be 0.866. Okay. And we're dividing that by the 5 square roots of 3. Well, if I take 0.866 and divide this by 5 square roots of 3, we will get 0.1 as our solution. 0.866 divided by 5 square roots of 3 will give me 0.1. Okay. So the sine of A over BC, this stemmed from the sine of A over BC, sine of A over BC. And what we got was the sine of 60 over 5 square roots of 3. The second one was the sine of C over AB. The sine of C over AB. And so the sine of C again was the sine of 30. So what's the sine of 30 here? Well, the sine of 30 is 0.5. And I'm dividing by AB, which is 5. And what we'll find out here is 0.5 divided by 5 is again 0.1. And we got these to be equal to each other. And I said, and I alluded to, that this idea of sine of A over BC as equal to the sine of C over AB is what we're going to come to find out is the law of sines. And I'll introduce to that on the next slide. But let's look at question number 2. And question number 2 states do you think the ratios would have the same relationship in any 30, 60, 90 triangle? And explain your answer. Well, what we should have found out is yes. This should always be the case. Because, I should say yes, because the ratio of the sides are the same for every 30, 60, 90 triangle. And what I mean by that is, well, let's even look at this 30, 60, 90 triangle, but let's say that this is, let's think about what we were doing on Tuesday, and let's say that this is not 5, but instead let's say that this is 6. Well, if the side opposite of 30 is 6, well, we knew that the ratio between the 30 side and the 90 side, this angle across, the side across the 90-degree angle is double. So it's double the side across the 30 degrees. So across the 90 degrees should be equal to 12. Again, sorry, I kind of worded that really poorly. But again, we found out on Tuesday that the side opposite the 90-degree angle is double the size of the side opposite the 30 degrees. So if the side across the 30 degrees is 6, well, the side across the 90 degrees is double. And here we would have had 6 square roots of 3. Okay. And what we would have found out here is this would have been 6 square roots of 3, and this would have been 6. So as what we'll find out is, well, the division will happen at the same rate. The division will change from 5 square roots of 3 to 6 square roots of 3, and the division will change from 5 to 6. And so this proportion here is going to be preserved. The proportion between BC and AB is going to be preserved. Okay. And that's going to be true for all 30, 60, 90 triangles. Okay, those ratio of the sides, 6 square roots of 3, and 12 are the same for every single 30, 60, 90 triangle. 1 square root of 3 and 2. Okay. And if you wanted to, you could figure out what this would be with 6 square roots of 3 and 6. Okay, and actually, let's even do that. Let's think about this. Sine of 60 is still going to be 0.866. And so 0.866 divided by the quantity 6 times the cube is the square root of 3. And we'll get 0.08. If this was 6 square roots of 3 instead of 5 square roots of 3. And right here, this would be 0.5 divided by 6. And I would get 0.0833 again. So this should still be the same. Okay. And if you really wanted to, we knew that at this point, the sine of A over BC was always going to be equal to the sine of C over AB. That's what we found out with question number 1. These two were equal to each other. Well, here, this would be the sine of 60 over, what I'm going to say is over x square roots of 3, no matter what the side for x is in the ratio, that should be equal to the sine of 30 divided by x. Okay. Well, in all cases, this is going to be x times the sine of 60 if I do my cross multiplying, and this should be equal to x square roots of 3 times the sine of 30. Sorry, I'm kind of getting to the edge of the screen here. But if you think about this, kind of giving you one kind of reason as to why 2 is correct, if you think about it, no matter what x is, I could divide by x to both sides and they will go away. So I could, in theory, put any value in for x, whether that be 5 and 5 square roots of 3 here, or 6 and 6 square roots of 3, or 1,000 and 1,000 square roots of 3. If I divide by that number, in this case, it would be either 5, 6, or 1,000, those are going to cancel out. And every single time I'm going to get sine of 60 going to be equal to the square root of 3 times the sine of 30. And that is true, okay? So this relationship between 30, 60, 90 triangles preserves no matter what the side lengths are, as long as you follow that same ratio that we have here, as the ratio being 1 square roots of 3 and 2, okay? So I know that was kind of a long-winded answer to question number 2, but overall, the answer to question 2 is yes, okay? So moving on to actually what we're going to be focusing our time on today. Again, what we've already kind of alluded to is this topic of discussion is this law of sines. And so the law of sines is a special law in trigonometry with trigonometry because we can use the law of sines on any triangle. So far when we've been talking about trigonometry, we've been focusing our time on solely 90 and right triangles. Now we can do with any triangle that we have. Okay, although this says in any right triangle, it does follow through with every triangle that we have. This can be any triangle, in any triangle. So it's not necessarily any right triangle. It does work with right triangles, but it is in any triangles with side A, B, and C, the following property exists. The sine of A divided by A, which is really the sine of an angle divided by the opposite side, is equal to the side of another angle in the triangle divided by its opposite side. Okay. And the sine of the third angle divided by its opposite side is equal to the other two. So, taking a look at this. Again, pause the video if you need more time to think about this. But again, all it's saying is the sine of an angle divided by its opposite side is equal to the sine of another angle divided by its opposite side. And that's the law of sines. So what I would like for you to do is take a few moments and try to answer question number 3 and question number 4. All right, pause the video if you haven't already, and then try question 3 and 4. All right, taking a look at this. At this moment, question number 3 asks us to find the side length for xz. Find the length of xz. Okay. Well, in order for us to find the side length for xz, again, the rule states, this law of sines states that an angle, the sine of an angle divided by its opposite side. So in this case, the sine of 77 divided by its opposite side. The opposite side to 77 is 7. Should be equal to the sine of, in this case, y divided by xz. Again, y and its opposite side, xz, which is what we're trying to find. Well, we're in a little bit of a trouble, rock and a hard place here, because we don't know either xz, which is what we're trying to find, and we don't know what the angle for y is. But if we think about our rules with triangles or our properties with triangles, I can find the side that last angle. Well, and again, that all stems back to that we know that the 3 angles in a triangle add up to 180. So we can say, well, the last angle, angle y, is equal to 180 minus 51 minus 77. That should be equal to the measure of angle y, the last angle of that triangle. So 180 minus 51 minus 77, the measure of angle y is equal to 52. And I forgot the y here. Measure of angle y is equal to 52 degrees. And this is enough for me to solve this proportion here. The sine of 77 divided by 7 is equal to the sine of 52 divided by xz. Okay. I'm going to have you round this to the nearest tenth. So if we cross multiply at this moment, just like how we were solving proportions with similarity statements, we're going to be doing the exact same thing. We're going to cross multiply here. And what we'll end up getting is the sine of 77, multiplied by XZ is equal to the sine of 52 times 7. Okay. And at this point, the sine of 77 is 0.97. Okay, and the sine of 77 is sorry, I've had some dog issues and my sister just walked in, but sine of 77 is 0.97, 0.974 times by XZ is equal to the sine of 52, which is 0.788, 0.788 times by 7. Well, 0.788 times by 7 is going to be 5.51. That should be equal to 0.974 times by XZ. Okay. And now we're almost done. We are almost done. And now we can solve this by saying 0.974 times by XZ is equal to 5.51. And I can divide by 0.974, divide by 0.974. Sorry for my bad handwriting. But then we get XZ to be equal to 5.7. In this case, XZ is 5.7. Okay. Number 4, look for make use of structure, find the measure of angles R and angle 7. So angle S. So at this point, what I can say is, again, we're going to use the law of sines. I know that I can say, well, the sine of 74 divided by 12.3, because again, it is the sine of an angle divided by the opposite side. Well, the only thing I know now is RT, which then I can say, well, that should be equal to the sine of S divided by, I'm going to move this over a little bit. I'm going to move the sine of S over here. Sine of S divided by 12.7. And at this point, I'm going to cross multiply it. But I also want us to kind of stop and think about this question. Here they're asking us to find angle S. Well, I have the sine of S here. In this case, we're using the law of sines. And before I said, well, if we're ever trying to find an angle, well, what do we have to do? What do we have to use? Well, we have to use, again, to take out the S from the sine function, we're going to have to use the inverse of sine. So at some point during this whole process, I need to use the inverse of sine. And so at this point then, I'm going to get, when I cross multiply, the sine of 74 being multiplied by 12.7, that should be equal to the sine of S being multiplied by 12.3. Well, the sine of 74 is 0.9612. And again, I'm multiplying this by 12.7. That should be equal to the sine of S times 12.3. And 0.9612 being multiplied by 12.7, that will result in 12.21, and that's equal to the sine of S times 12.3. And again, we got this equation based off of cross multiplying. Okay. We got this top equation by cross multiplying, sine of 74 times 12.7, and then 12.3 times the sine of s. And then again, we just simplified sine of 74 and that to be 0.9612. And then what we did here is 0.9612 times by 12.7 to get 12.21. And at this point, I can divide 12.21 by 12.3, and I am going to get 0.992 to be equal to the sine of s. 0.992 is equal to the sine of s. And now at this point, again, back to what I was referring to earlier. Now I have the sine of s to be 0.992. Well, to get the s out of the sine function, I need to take the inverse of sine. Take the inverse of sine of both sides, because an inverse and its first function, its original function, cancel each other out. And so what I'm going to get here is the inverse of sine of 0.992 is equal to s. And what does that give us for the value of s? Well, then that would give us, second sine, that gives us 82.95 is the value, 96 is the value for the angle s. Angle s is 82.96. And at this point, we can find angle r pretty easily because we don't need to know what st is. If we did know what st was, we could do the law of sines again and then do the cross multiplying idea one more time. But we don't even need to do that because I know two of the three angles in the triangle. If I add them all up, I can find the third side. So I have 82.96 plus 74, and I'm going to take that away from 180, and I get 23.04 is the value of this third angle. Angle R is 23.04. And again, we got this from doing 180 minus 82.96 for angle S minus 74 for angle T, and we got 23.04. Okay, and so that's how you solve question 3 and 4 at this point. Okay, pause the video if anyone needs to catch up on the writing. If you have any questions, ask someone around you or a friend, and hopefully someone can answer these at that point. Okay, pause the video, but I'm about to erase all this stuff on the screen now. Okay, I've taken a look at this. I don't think I'm going to get to the law of cosines because this video is pretty long already itself. I'm going to skip it. I'm only going to be pretty much quizzing you on the law of sines, and we're not going to get to the law of cosines. Okay, but number 5, reason abstractly and quantitatively. The map shows the path a pilot flew between Omaha and Chicago in order to avoid a thunderstorm. How much longer is the route than the direct route to Chicago? All right, so let's kind of make a game plan here. So normally a plane would go straight from Omaha to Chicago or vice versa, depending upon where it was starting at. Okay, and that length was 471 miles long. Okay, 471 miles long. But instead, a pilot had to go from Chicago to this turning point, wherever this is, and then from this turning point to Omaha. So our goal is here to figure out this length here from Chicago to the turning point, figure out this length here from the turning point to Omaha. Once we do that, then we will add together those two side lengths because that's the total distance the plane flew. And we have to compare that in respect to how long it took the plane, the 471 miles, how long it took from the plane from Omaha to Chicago. So now what we're going to do is we're just going to do the law of sines one more time. So I have this triangle here, 113 degrees at the turning point, 22 degrees at Chicago, which means at Omaha, this is 45 degrees. Again, this goes back to this idea that 180 degrees forms a triangle, and I already have 113 and 22, which means the third angle must be 45. This is 180 minus 113 minus 22, and that gives me 45. Okay. Now what I can do is approach the law of sines. And it says, okay, well, the length of Chicago to the turning point should be equal to, and I forgot I'm already typing in white, should be equal to the sine of 45 divided by here, divided by, I'm going to say CT for Chicago to the turning point. So 45 divided by the opposite side, CT, that should be equal to, type this out, that should be equal to the sine of 113 divided by the opposite side, 471. 113 divided by 471. Okay. Well, again, let's cross multiply here. Let's cross multiply. And let's say, okay, well, the sine of 45 being multiplied by 471, that should be equal to the sine of 113 times by the value of CT. Well, the sine of 45 is 0.707. So the sine of 45 is 0.707 times by 471. That should be equal to the sine of 113. And the sine of 113 is 0.92 times by CT. I'll do 0.921. Okay. Well, 0.707 times by 471, that is equal to 332.997. Okay. So 332.997 is equal to 0.921 times by the Chicago to the turning point length. At this point, I can find CT, or the Chicago to turning point, the length of this line segment, by dividing by 0.921 here. And so that will give us 361.56 is equal to CT. And again, this was determined by dividing by 0.921 to both sides, because these will cancel out, 0.921 to both sides. And so this length right here, this right here is 361.56 miles. Okay. What I want you to do, if you haven't already done so, pause this video and try to find the Omaha to turning point, and then also see how much longer did it take for the pilot to go hit the orange route in comparison to the pink route. Okay, now take a look at this. As you can see, I kind of filled in the remaining parts here as well. But the sine of 22 over the TO is equal to the sine of 113 over 471. Again, in this case, we're using 22 as the reference angle. So the sine of 22 divided by the opposite side, which is TO, should be equal to the sine of 113 divided by 471. Okay. If you wanted to, you could have also did, for the second fraction here, you could have also done the sine of 45 divided by 361.56, and you should still get the same answer. If someone did it that way, they should still get TO to be 191.78, as you can see at the very bottom. But at this point, if I cross multiply this proportion, it should be the sine of 113 times by TO. That should be equal to the sine of 22 times by 471. And we already said in the previous proportion that sine of 113 is 0.921. So 0.921 times by TO should be equal to the sine of 22 is 0.375. So 0.375 times by 471. And 0.375 times by 471 is 176.625. That's at this step right here. And then divide by 0.921 and you should get 191.78. Okay, we just solved this just like how we solved this over here. And now at this point, I can say that the total amount, or the total, I guess, amount flown was 361.56 plus 191.78. And that is the sum of these two orange lengths right here. That will give how far the plane flew from Chicago to the turning point and turning point to Omaha. And this should be equal to 191.78 plus 361.56 should be equal to 553.34 miles. So how much longer was the route? The route was, subtract the 471, this route was 82.34 extra miles. Okay, took the 553.34 and subtracted 471 to it. Okay, this is all I'm going to have you learn because, again, the law of sines, this was a longer video, and the law of sines is an important topic. And we're just not going to get to the law of cosines. It is a little bit longer of an equation. And I think this one is a little bit easier to recognize, easier to remember. And so I'm just going to stick with the law of sines here. And again, what the law of sines is, and I'm going to erase this. So if someone still needs it, please hit pause. But what the law of sine is that it really just states, just going over it one more time, that the sine of an angle divided by its opposite side is equal to the sine of another angle of the triangle divided by its opposite side. So sine of A divided by A should be equal to the sine of B divided by B, which should also be equal to the sine of C divided by C. And this is true for all triangles, not necessarily right. Here I have it as right, but it does not necessarily have to be a right triangle. Okay. Please email me if you have any questions, or you can ask me either next Tuesday or next Friday. Let me know and have a good weekend. Oh, also make sure you do your quizzes and your homework in today's folder as well. Thanks.